Okay, thank you to be here for the last lecture of this course. First of all, really, it was nice again to meet you, to have the possibility to teach at your university. And this last lecture, as each last lecture, at least in my context, in my courses, in a particular lecture, if let me say the program or the course is oriented to a project. Of course, if the course is oriented to an examination, a formal examination, the last lecture is dedicated to recap, to do exercises, or to do something like an examination test. And here it's quite similar. No? We will reconsider again the topic, but in the context of the possible projects. Let me open and then we will see also rules and then in particular what I intend. In the email which I sent, and in my camp, in WeCamp, excuse me, I will upload also the same file. You can find four, let me share, no? Four possible projects. Now, each group, this means the group could consist of one student, two students, three students. Yeah, sometimes some students ask me, but we working also in a group of four. It's not really exactly what I wish. The best group is two students because you should communicate, you should exchange. Three students is also possible because it's possible. One, I mean, the mean value, the desired value is two, and this means you can work also alone, no problem. This means the variance, let me say, roughly speaking, colloquially speaking, is one. I mean, three students also possible. Four students, I don't see necessary, but okay. In some cases, it could be also allowed. Now, you can choose one of these four projects, let me say so. You can realize that the project or the question is not exactly the project. The word project during the semester, do you remember? I already told you project because the idea is to, now we will see in detail, you have to answer the questions, but what is the meaning of answer the questions? The meaning is to produce the software which answer the questions. This means in this report at the end, you should include the results which you obtain using MATLAB Simuli. And very important, each question, and we will see, is related to what we did during the semester. This means the idea is download my software. Look, my software means you have to recognize, but this is easy. You have to recognize which kind of software, let me say, files, MATLAB or Simulink file fits the question. Then you have to modify. Very important, the discussion. This means, what is the discussion? Now we will see in specific case. This means if I ask, please analyze what changes, if, I don't know what, I change the parameter, now we will see in detail, the parameter K of the controller. Do you remember, as we did in the lecture, we discussed together the results, the simulations. This should be reported in the final report. As, let me say, discussion of the results. Now we will see specifically question per question. But the exam of the project, why I told you about project, because I need not only the report in PDF, in Word, better PDF, but also the software related, the MATLAB Simulink file related to each question. I mean, the answer of the question, better to say, the answer are supported by the analysis which you did with the MATLAB Simulink files. Exactly what I did for you during the semester. This means if you want, you can also look at the YouTube presentation in order to understand a little bit the meaning, what I now in general told you. Let me go now in the project number 1, test 0,1. Please pay attention. We have 4 possible choices, but I will open just in a couple of these 4 because you will realize that I changed just basically some numbers, a little bit more, but believe me, the test is the difficulty of the test are the same, believe me. And everything which I am asking, I explained, and you can use, very important, I suggest to use my software. Or now we will see in detail. As I told you in the email, as I wrote you in the email, as I wrote in the email, I didn't include MPC. Now, even though I dedicated a couple lectures, but MPC is a little bit difficult. Therefore, my idea is now writing to everything, to everyone, an email in which I will clarify where can eventually, as a plus, something optional, you can eventually, in a very easy form, include also this. But it's not mandatory. Because look at the MPC, we have seen basically, or at least simulated just one method. This is enough to formulate an exercise. But I think it's really an advanced selected in any case could be very good justified. In my opinion, now we will see as an optional example. What is an option for you practically? If you make some mistakes, or something not so detailed answer in one exercise, if you decide, if you understood very well, if you like MPC, you can also use this option. Let me say to compensate what sometimes another topic was not clear or you don't like, but it's an optional. Again, why that? Because even though I dedicated more than one lecture, but isn't a topic a little bit not so in accordance with the time which I dedicated. You have to see that here I have a course, just a course in MPC. But of course, if I dedicate a course, you can understand that we are proceeding with a different tempo because we have time, and then we will start with the controllability concept, the predictability concept. Anyway, is different. Therefore, this difficult, even though selected, I would like to offer you as an option plus. This means it could be that somebody you liked, somebody you already know, and then you can use. But it's optional. It's not. Let me go in depth a little bit in detail, so we can also speak about some technical aspects. Look at this system here. We have a system with 2 states. Let me enlarge it a bit. x1 dot equal x2, x2 dot equals something like that. We have seen many times this kind of system. Excuse me, here in LaTeX, I have A capitalized, B must be capitalized, C must be capitalized. In this line here, the indication is clear, indicated, excuse me, for LaTeX. Yeah, I have to remember that this formal error, let me say, is theirs also last time. It doesn't matter, but it's clear what I intend. The matrix A, B, C capitalized, which is indicated exactly in the second line, the last line. Describe 1 using the matrix A, B, C, D. It's clear that I intended what is written here in the indication, in which the output is 1. This means the matrix C is clear, the matrix 1, 0, no? Just to understand what intended. C capitalized. Excuse me for this, probably. I think I corrected, but LaTeX, you know LaTeX probably. the state which I am considering x1 and x2. This means this example, this question one is just a mathematical exercise, easy. You can then put in the report in Word and LaTeX if you want. You can do also by hand and then take a picture, include in the report. The report can be done in Word, but at the end, it's better to fix in a PDF. At this moment, no simulations. No, it's not required. Look at the question number 2. Look at the question number 2. Now, we consider always the exercise number 1 because I didn't mention any other system. And it's clear, no? Because we have an exercise with question 1, question 2, and then we have another exercise with question 1, question... yeah, yes, again, we have another LaTeX error, excuse me, again. Q2, Q3, yeah, but... Oder? Yeah, it's LaTeX, excuse me, but it's intuitive. No, this the list of the question is clear. Let me come back here. Now I reconsider again the system 1 and this question 2, and the idea is that to control the system using an integral state space control. Do you remember this? I presented this integral state space controller as the, according to what I told you, the most important controller which we consider in this course, because I can place all eigenvalues of the system 1. Do you remember here the physical system? If 1 is the physical system, and the sense is the description of the physical system, of course, the physical system is something more which I can see, I can touch. This is the mathematical description. I have the system here consists of 2 eigenvalues. Just a remark in order to be more concrete. This system here, or this model represents, can represent, for instance, but not only, can represent a massa spring damping system. We have seen this together. Practically, can represent also an electrical system in which we have resistance, capacitance, and inductance. Just to be more concrete. But of course, in the exam, during the semester, I tried not to show you more concrete, how concrete can be, or better to say, using this mathematical abstraction, we can solve problems in terms of in the context of automation, in the context of robotics. Do you remember the Segway? I didn't put the exam in the Segway because, in my opinion, is too complex. But you remember the idea. Okay, here, basically, I have to track signal V equal 1. V is a little bit a strange characterization of the reference, but anyway, x1 is the variable which I have to control. This means I have an x1 desired, which I called here V, I don't know why, equal 1, easy. Instead of put, I don't know, x1 I told you could be the position, remember, of if I consider the system as a mechanical system. If I consider an electrical, it's an electrical element or variable. 1 means if this is in a position, 1 centimeter, could be 1 meter, doesn't matter what. I didn't do really, I didn't characterize the system in terms of physics, but can be. Could be anything in terms of if this is mechanical systems. Why I speak about mechanical system? Because you remember robotics, automation, yeah, recall me more mechanical system. V1 is the reference signal for x1. the choice of the nomenclature is a little bit not so happy in this sense. But in any way, I have to follow, I have to track, better to say, to track one constant, a typical example uh, for this system here, the system one, using an integral state space controller. In particular, I have to track this without oscillations. Do you remember this? This means the eigenvalues must be real. And of course, in order to track, I have to guarantee the asymptotic stability. This means real with real part negative, strictly negative. Do you remember my theoretical legend, I would like to say? Moreover, rising time less than 1 second. Do you remember about the rising time? We did in a couple of exercises. Of course, here you can also heuristically works with MATLAB. Typically, we do heuristically with MATLAB Simulink, checking the position of the eigenvalues in order to obtain rising time less than 1 second. Now, here I didn't put the definition of the rising time. Why that? I didn't put, as I told you during the semester, because you can find the literature different rising time. Of course, but you can ask me, but I don't know what you intend, it could be that they made mistakes. No, it's impossible to make mistakes because you can write in the report that you assumed the rising time 70% of the final value. Or you can write, in my opinion, the rising time is 90%. Why that? Because in the literature we find a different definition in accordance. Why different definition? In accordance of the application. Here, I didn't speak about the application. This means makes sense to say rising time. If it's not specified, you can specify directly. The rising time, I don't know if you remember, is the time which you can consider in which I reach the final value. But in this case, we'll never reach the final value because we don't have oscillations. This means we are reached in infinite time. This means this definition is not exactly correct. It's not feasible. This means you can consider 90% if you like. You can consider 80%. Now, practically, theoretically, do you remember, this is related to the time constant of the system. But here, at the end, once I controlled with the integral, we have 3 eigenvalues. This means 3 time constants. What I have to consider to have an idea about the rising time. There is also a way to calculate exactly, but we didn't do. Basically, practically, we consider the dominant. Do you remember the concept of the dominant rising time? You can find in the material if you don't remember, but it's easy to remember because the dominant rising time, the dominant time constant is characterized by the largest one time constant. This means, do you remember, 1 divided absolute value of the real part of lambda. That we can find this equation in my lecture in the material. Why this is the dominant? Because it's the rising time which remains. Yeah, just a second. I come. Just a second. I stop and I come to you again. Now, how I can stop? Yeah, basically, I told you before that you can fix as you want this rise in time. Basically, rise time means the time in which I am satisfied, let me see, with the level which I achieve of my goal. No, 1 is my goal, 1 meter, doesn't matter what, 1 centimeter, this is irrelevant what. And you can consider 80%. Typically, I think it's around, I don't remember, 67%, something like that, but it's not fixed in the sense. The idea was how you can also, let me say, play trial and error with the position of the eigenvalues. the real part of the eigenvalue. But you remember I told you this, the dominant time constant is approximatively uh, this rise in time, no? This rise in time, approximatively. This means we did also in an example in discrete in this sense, but it doesn't matter if discrete or not. This means you can, in this sense, consider, you remember, tau, the largest tau is the dominant, because it's the correspond to the exponential function of the answer, which is dominant. You remember, which is dominant means is not extinguished very fast. If you remember in the lecture, you can find in the material exactly that. Yeah, if you want, I can reconsider this theoretical this background in order to understand what I intend with this question better. 1 second. Yeah. Let just make sense a little bit to. It nevertheless is in a lecture, not today. This means it makes sense to repeat in order to understand better. This is the goal, to be here. 1 second. Okay, let me see if I'm able to look what I intend. Assuming that each one of the free answer. Do you remember I told you about the free and forced answer, I think, no? You remember I told you the controlled system at the end, we will have a1 exponential function lambda 1 multiply t plus a2, the free answer. Free answer, do you remember I told you that I don't put any input. I put initial conditions, and I will look, yeah, the answer of the system, just consider the initial condition. I think I told you that, but it's not now the topic of the examination. As I told you, we have three eigenvalues. Do you remember in a system which consists of two states, x1 and x2? And if I consider if I want to control the system considering an state space plus integral in the concept of state space, we have to consider the dynamics of the controller, which is an integral. This means which consists of an integral too, and this means we have a dynamics also of the controller. This means we have three eigenvalues. I told you a lot about that. But what is here the rising time? Here in the free answer, the rising time, assuming that lambda 1, lambda 2 are real, no? Lambda 1, lambda 2, lambda 3 real eigenvalue. Real, yeah, why not? Eigenvalue is correct. Negative, no? Negative eigenvalue. Here, the rising time we can consider, I don't know. I have to reach, in this case, the goal in the free answer is fixed by 0, because I don't have a step in this sense. Or a goal to reach is just 0, the goal in the free answer. Here is basically 10%, 90% of the goal. What is here the dominant? The dominant is characterized by the smallest lambda in absolute value. This means, assuming that lambda 1 less than lambda 2 in absolute value less than lambda 3, we have the tau dominant equals 1 divided lambda 1, because this is the largest one. What is the meaning of this? If I consider separately these three contributions, starting from an initial value, we have three answers in which this here, which dominates, is easy to remember, is characterized by lambda 1, let me say so, which associate the dominant. Because this dynamics extinguishes slowest than the other one. This means we can consider also here to calculate the rising time. What is the mean to calculate? If I have the rising time equals 0,9, in our case, it's something like that. This means that the T dominant, tau dominant, circa 0,9. Circa because, of course, we have the three contributions, but we can consider also just one. This means one eigenvalues, in this sense, the smallest, must be circa minus 0,9. This is a little bit the idea. To consider this dynamics, which is the fourth dynamics in the language, because we have an input of this dynamics here in the context of the calculation of the rising time, it does not matter. Here, in the free answer, the goal is 0. Just to remember you what we did during the semester in this sense here. Of course, no oscillations, as I propose in the examination. This is characterized by the real. Negative because I have to guarantee the stability. Remember, this means I need to achieve this, excuse me. Otherwise, if it's unstable, I go far away. The same here, no? Could be oscillating, could be far away. Both, let me say, dynamics, not correct to say profiles or answers, but say answer asymptotically stable, because I will converge to the goal asymptotically. This means asymptotically stable. Asymptotically means in infinite time. No? You remember I insisted on the finite infinite time because this was related to we have seen not much on finite time because I didn't have time, but to achieve something finite, I didn't tell you really. A little bit in the context of sliding. Exactly in the context of sliding, now look at this. I modify in the middle of the exam this system here. We can see that is quite similar. The first equation is totally similar. This part here is exactly the same, but we can see that I add something here. Do you remember I told you the meaning of this? In a mechanical system, this can represent, I insisted at the beginning of the semester, and then I insisted, can represent the Coulomb together with this, no? Together with this. Basically, this part here can represent the Coulomb friction of a mechanical system. I mean, here we have a friction, but it's a linear one. Here we have a friction which consists of the same linear part, plus, remember, the friction elements and the quadratic one. SGN represent an element extremely important physically because states that this friction is always against the movement. X2 is the velocity if you consider the mechanical system. And here we don't need SGN because this function is an odd function. This means depending of the sign of the direction of x2, the sign of x2, I will change the sign of its contribution. If x2 is positive, is in the direction of the movement, we try the description says that this friction is against the movement, but here I need something which express to be against. Why that? Because this element here inside is not sensible with respect to the sign. It must be. I mean, just to let me trivialize the concept. We are here to repeat a little bit also what we learned during the semester. If I go in this direction, the friction is against the movement. If I go in the other direction, the friction is always against of the movement, because the friction is in the physical lack, laws, better to say. But if I model the friction using even function, of course, this must be multiplied by SGN. I can show you again a little bit what you already have in FR. I think I called here FR the friction as a function of x2, which is the velocity, no? Could be the velocity. Because x1, we assume that be the position, in order to figure out what I am doing in a robot, in an automation system, something like that. x2 is the velocity. No? Do you remember? x1 derivative equal x2. No? If x1 is the position, its derivative is the velocity. Now, if this equals x2, or this 3 times x2, I don't remember, 9 times x2, I don't remember what. Let me see, 9 times. Of course, in the balance, I have to consider the minus, but in this case, you have something like that. This means if I am traveling faster and faster in the positive direction, I have more and more friction. Huh? In the balance appears with minus. No? It doesn't matter. Now, if I consider now the FR of x2 equals what I wrote here, 4 plus 9x2. Again, the sign in the Newton balance is minus. But here it's just to conceptually, let me say, to represent. This here, if I write so, that is not correct. Because this 4 does not change with respect to the direction of x2. I don't know if this is clear. If I have to represent this, I have a line here. Something like, if this is 4, I have something like that. This means why this is not possible physically. Because even though the direction changes, I have the same sign of the friction. This means if this is opposite, is again opposite, even though I opposite the velocity. This means here contribute to the movement. This cannot be. Therefore, do you remember this? I told you a lot. Must be something like that. And this means FR of x2 is 4 SGN of x2 plus 9x multiply x2. Everything is in a function of t. And this here represents exactly the static friction. In one direction, I have to overcome 4 in order to start moving. As long as I remain here with the resulting force acting on the system, the resulting force, everything, inertial force, input force, I don't move. No? Here, I don't move. As long as I don't overcome 4 or minus 4. And then I will move. As long as I am here, x2 is equal to 0. Just to repeat, I don't want to insist because probably I'm boring because you know. What about if I add in a quadratic form? This means in accordance with our identification method which we used. You have something like that. The difference between that we assume, in this case, we assume it could be that using an identification method. About the identification, I didn't tell you in the course because it was control, not the course. I have that the force changes with respect the friction force, no? Change with respect to the x2 as in a quadratic, or better to say, in accordance to this law, let me say law. I don't remember, it was x2 squared, or we have a coefficient, let me see, x2 squared. Again, as Gn of x2 of t. Basically, I need Sgn as here because the function which I included in the model is an even function. An even function. This means even is not sensible to the sign, but we need to sensibilize, let me say, to sensibilize our model with respect to the sign of the velocity, because the contribution is always against the movement. A little bit, think about what I told you during the semester. Okay, let me go ahead a little bit faster now. The question is basically control the system 2 using sliding mode control, considering the same specification of the system 1. I see that LaTeX didn't work. Sliding mode control. No? I forgot the M. Excuse me again. But it's clear what I intend. You can choose as you want. Look at the example which I did. Again, the question here is again the error in the Q. You consider again the linear system at the beginning. You do 2 possible representations, forward Euler, backward Euler. You can choose TS as you want. Remember the criteria which I used to consider TS should not be so large, streamline should not be extremely small. Typically, we can consider 10 times smaller than the dominant time constant. Something like that. I didn't tell you much about the choice of TS, but we did a little bit. No? Not so large, because otherwise we can end up as an unstable system. To guarantee, nevertheless, the stability, to say that 10 times smaller than the dominant constant is not enough. It should be take into consideration the fastest, remember this, the fastest dynamics. This means we have to consider relative smallest than the fastest dynamics. Typically, I don't know if you remember, but I did insist much on this 2 times fastest of the fastest dynamics. But anyway, this I don't pretend. In fact, we have seen a little bit in the lecture. You can again lower the lecture to look at this. And I would like to anticipate that this is for the forward-Euler is extremely important. For the backward-Euler is always stable if the original system is stable. This means in backward-Euler, we don't have problem of stability. As I told you during the semester, for forward-Euler, we have to be careful. And again, to be really sure that is asymptotically stable, should be at least 2 times faster than the fastest. But roughly speaking, very often we consider the slowest, but it's not really exact to analyze the stability. The fastest, because the fastest can generate, if you remember Euler instability, if it's not sampled fast enough. Then here, question number 3, design a discrete controller. Again, integral state space, we did a couple of weeks ago, with guarantees again, the specification here, but basically is exactly what we did in the exam. We have to just basically change the original system, the given system. Then we will conclude here, and then we will discuss where I can put the MPC, design a Lundberg observer. Remember, we did in the last lecture, you have also the software, in which I measuring x1 in everything in discrete form. Of course, exactly in the lecture, exactly in the software which I sent per email and will upload now. And x2 is estimated. This means assume to measure x1, I estimated x2. Now, please pay attention here. At the end, I put you connect the observer with the controller realized at point Q3. We are in the discrete form, no? Everything is linear nowadays. Yeah, now, let me see what I can offer as an optional. My idea is as an optional. I will send you officially to everybody per email. In Q3, I would like optional, but I will add per email is try to implement, and I will upload, I will send you with this email the file MPC which you can use if you want, but it's not mandatory for the examination, but could represent the plus to control Q3 the system using MPC. The specification are basically the same. Instead of the the integral state space, discrete, we are able, with the same specification, try to connect the software and to adapt the software which we discuss in MPC. We discuss just one method. This indication I forgot to say. Do you remember I told you that the rising time, 1 second, no? Yeah, look, the rising time was 1 second. Typically, to remember I told you in the last lecture, the observer, in any case, must be faster than the controller. Otherwise, I cannot give, let me say, in the real time, the estimation of the state. This means it must be faster than the dynamics of the controlled system. Typically, we consider 10 times faster. This means, yeah, this is in a rising time like. What we can do, we place the eigenvalues. Oh, let me say the smallest eigenvalues, which represent the largest time constant, 10 times faster. This sense. 10 times faster means the eigenvalue 10 times larger in absolute value. I mean, we calculate before. No, let me be concrete in this. This, please pay attention. This was continuous. This was everything continuous. We have to transform in discrete. To remember, with the forward Euler, we did together. But let me remain here, so it's easy. And then the transform you can see in the M file in the lecture as you want. 10 times faster, the observer. This means 0,09 in continuous. And then, of course, you have to transform with the transformation of the forward Euler in discrete. It's clear that to control a phenomenon, with an observer, the observer must be faster of the controller. Otherwise, do you remember the observer, the task of the observer, basically the out goal of the task is to let me say give the states which I cannot measure, in general all states, even though the state which I measure, here's the topic which I didn't tell you about the Kalman filter and optimal estimation. We spoke about just estimation without including any optimality. But in any case, must be faster. Otherwise, we have a discrepancy in time. I mean, if I were to control the system with the very, let me say, past data, it could be like there is a problem. I mean, we have a phase delay in this sense. So we didn't do this test. Could be, and also in the U analysis, you can add also this test. I mean, you can consider 1 times 10 times faster. We can consider 10 times slower, and then we realize if you control the system with an observer, with a very lazy, also the controller, we have to wait a lot of time in order to obtain the steady state, and if something change, of course, we cannot satisfy the specification. For instance, this rising time 1 second. Now, if you look at the other example, it's basically I change just the number. I will open just another one. Then we take a rest. I try to find something to tell you. Let me see the second one. Let me open this. You can realize that they are quite similar. They are so similar that I see that the same LaTeX error, no? But we clarified already this. Look, really extremely similar. Instead of 1 here, I have 2. I don't remember here. I had don't remember which value. but it doesn't matter. Here you can see instead of 4, we have 1. Must be so. I cannot be really put totally different questions. Here is extremely easy in the sense. To be fair, I propose 4, yeah, uh, example or exercises, but basically the same. You can see also along the other examples, example of projects that is basically change just formal things. Let me see if I forgot to say something now. Excuse me for this LaTeX, but sometimes the LaTeX, also, do you remember I wrote sliding mode instead of sliding mode? I don't know if it's a problem with the compiler, or but I thought that I corrected, but it could be also a problem with the compiler. I don't know if you know LaTeX, but it's clear what we intended. There's no ambiguity. A capitalized, B capitalized, not capitalized, everything is capitalized. Ode does not exist, sliding mode. Let me see what I can add now before taking the rest, because here in Lunenburg is extremely hot. I don't know in Huch. Um, this I told you, the thing I told you. Now, waiting. Now we take a rest. I look for some material to tell you. Then your questions in general. Otherwise, next step, I completely upload in WeCamp today. I must, but you received already everything. But I will send you this optional part. Again, it's not required to receive the maximal mark. This is enough what officially I put in this PDF files. But of course, optional means it's just an advantage in the sense I will send you in this mail. Clearly, it's an optional. Optional means sometimes you don't like the example number 1. I don't know what. Even though it's a little strange because the example number 1 is related to the example, to the exercise. The exercise number 1 is related to example number 3. But anyway, you don't like continuous and or make some mistakes in the continuous. During doing the discrete, you can also implement the MPC. I will include the email. I will put in WeCamp. The lecture is there, the presentation, but I didn't upload the software. I will upload and will send you in the email to clarify that in the example exercise of discrete can be optionally also try to implement the MPC together means after, in this sense, implemented the integral space, which we did also in the lecture. But also MPC we did, but really, frankly speaking, could be a little bit difficult because I think I told you in 1.5 lecture, and the topic is really a little bit, in my opinion, more difficult than the other one. But it could be that using my software, using the lecture, you can do that. Meaning is in the plus in case you have some errors or something a little bit too superficial, this analysis and discussion. You can compensate the mark if you put also this MPC. But it's not required. I mean, you can achieve the maximal mark, discussing in depth the results, answer all questions without considering MPC. Okay, let me take a rest. I would like to drink something fresh and then I come back. In the meantime, I'm thinking about to tell you something more connected with some problem which I left open, and also very important to hear your question in this phase. Before take a rest, nevertheless, let me show you the mail of Piotr of today, which fixes some time conditions. Let me see. This is the last one. It's not this. Let me look here. Piotr. Yeah, it seems to be that the first period of the exam, it seems to be 2 weeks. Really, this is enough. No, believe me, but I can ask some days more because I know that is the period of all examinations. Uh, in this sense, I need that some of you send me an emails to say we need a little bit more time based on some requests. I can ask, I don't know, in a week more. I can try. But based on new requests. This is very important. If some of you, you never do all students, but anyway, some of you, we will see if I'm able to obtain a prolongation. But believe me, it's typically the student realize this. Then when I receive per email and copy in Hooch, but per email lo ifana, so I can answer directly received. That you are sure that I received. Mm, I have I don't know how much time to uh, upload the mark. And then we have the second round. Uh, for the second round, I have to change the task a little bit. I will do. This means basically before this day, if you decide to do the examination here, I will reach you as today and day before, no? Basically 6th September uh, to offer to everybody the same conditions, of course. Of course, I will change a little bit, but not much. But I have to change, otherwise it seems to be more suitable to do here if the exam exercise are exactly the same. I will change a little bit, but always connected with the course. And again, I will offer on the 6th September, and the meeting is today. So everybody will receive the same conditions. But of course, the exam in September is a little bit different because otherwise it's not fair. I don't know if you understand me. If exactly the same, okay, this means it could be convenient to do in September. I don't know in which you already registered probably for the first call of the second call, but believe me, it's correct to say the second call I have to change something a little bit the question in order to I cannot put the same. It is correct, no? Because otherwise, the student who is waiting, in advance, 2 months in advance, or 1.5 months in advance, doesn't matter. The question, this is not fair. This means I will I will communicate that I will meet you on the 6th September to discuss the new topics, exercise. I will correct A capitalize, B capitalize, but this is irrelevant, of course. But I will change also a little bit the questions a little bit. But always, everything which I will ask, we did in the course. This means the material is the same. But I don't want to put exactly the same because it's not fair. Okay, let me take a rest a little bit to think about possible questions. Um, and then I can tell you something more, something I have to think such kind of problems we left open. But I will think, give me please half hour, a little bit to go to the bar to drink a little bit. Here I am in the lab. The university is extremely hot, really. We will see 45, no? 45. You take a rest, and then think about questions. And then the last part, again, if I remember something to tell you, I tell you. Otherwise, I answer your questions. And then together, or if you want, you can go. You can left me alone. I will update my camp, and in the mail which you received today, I will communicate my camp. Excuse me. We camp is totally updated, and this email officially I will communicate this optional exercise, which is as an option, not mandatory to achieve the maximal mark. But it's important because sometimes if you don't discuss correct in depth, if you make some mistakes, you can compensate with MPC. In particular, if you like MPC, if you want to do exercise in order to be confident in the future, no? Okay, let me close at this moment here, then we come back in more or less in half hour. Yeah, more or less. See you in half hour. Okay. What I have in mind, probably a little bit to tell you just shortly, and then I would like to hear your questions. Again, in the next days, please contact me for any, at Loifana, not Loifana, for any questions. If you send me some of you some requirement, if you need, I can try to ask for a week, something like that. But typically 2 weeks, if you now in this half hour, you thought about that this exercise is really basically what we did a little bit with a different uh, yeah, exercise, but the frame is the same, the sense. Um, yeah, again, let me reconsider the last lecture. Remember this observer, but the observer is, in my opinion, something easier than the MPC. Because the MPC, the concept of the prediction, anyway, it's not so. Therefore, it's an optional. Let me take the material here. I told you sometimes something because last time I think we left open the problem of the picking. Do you remember? The anti I told you the anti, yeah, the not minimum phase picking, why I'm speaking about anti, because you remember that the observer before understanding that the right direction of the state was, let me say, positive. The observer try to take in the wrong direction. And I try a little bit to clarify this intuitively. Let me show you. I don't remember. Mm, the simulation is there, of course. I put it. And remember, we reduced this effect. We tried to reduce or to eliminate this effect, reducing the gain, of the observer. No? Of course, there is also different techniques. I don't have time; it's really advanced. But the idea is to say that it isn't a problem in structural problem in the observer. All kind of observer have this kind of problem. Let me reconsider very shortly the observer, this problem conceptually, and you have the simulations. This means I don't want to resimulate, but you remember you can find again in YouTube, the file is there. I hope that I sent it, but anyway, I will upload also in WeCamp again. And let me take the material, and this is the unit thing. In this half hour, I realized that this was a little bit at the end, not very well, or not in depth. Analysis not requested in the exam. Huh? The analysis of this picking problem. I showed you what I intend. Just to recap a little bit. This makes sense to reconsider today because what it was the last topic. Mm. This is the model of the system which we consider. Again, with matrices, I told you a lot. The idea is that I measure the current, I have to estimate omega. Do you remember? Information about omega without direct measure omega. This is yeah, the issue. This is the problem which we can try to solve using observer. Observer. I don't measure direct omega. I measure the current. Now, C, the meaning of C represent the meaning is what I measure. No? Of course, C could have also a different meaning. Could have also the meaning what I observe. Sometimes in some literature we distinguish C and H, but in any case, in the context of observer, C represent what I am measuring. And the idea is to estimate omega because to control omega, we need in any case omega, not to build the error. In model predictive control, we need all states, even though I have to control just the current. This means the observer is extremely important in all kind of controller. In case I cannot measure a variable, which I have to control, but also in general, if I want to apply a model-based control system or strategy. Typically, if I measure something, it's also important to use an observer if the observer is an optimal observer. This means if the observer, for instance, filters in an optimal way the measured data. This is the case of Kalman filter, which is in a particular observer, but Kalman filter here I have in Loifana in all courses. It's not now in this course considered because there's more control. Of course, in the control, we can nevertheless consider an observer because it's extremely important to think that we have also special observers which can be useful even though I measure the variable. Anyway, this is the discretization. We did together, by the discretization, it doesn't matter if I have to discretize a system or have to discretize a model which is used, excuse me, if I have to define a model of a system which must be controlled, or if I have to discretize a model of their observer which helps to control. We have here forward Euler, backward Euler. You can reread everything to answer our questions. Let me see if I can show you exactly both. So probably it was, yeah, here is forward Euler, see too. But I'm sure we have seen once also backward. Yeah, yeah. Yeah. Which started from here, I think. Just a second. No, this is backward. This is forward. Backward started from here, even though it's not written, but I put this in another. Just a second. Non la so a lezione, dimmi. No, no, dimmi, dimmi. Ah, benissimo. Vai, sei bravissimo. Yeah, this I told you, but it's not written, but it's backward. You can find also in the theoretical, let me say, in the methodological lecture. Okay, the observer is here. The discretized observer is here, which you can see. No, yes, again, not yet, not yet. This is the discretized model. The observer is here. Just to repeat a little bit, in which hat means what I am observing what I am observing, the state which I am observing, which E is the error in the sense what I measure minus what I observing, and this signal here through the product LD multiply C. C is given, is 1, 0, because I measure the current the first state. LD must be designed such that, you remember, I told you a lot, let's see, such that this expression, which is in a discrete form of the dynamic of the error, which is here in continuous. But you remember, I told you reconsider in a lecture, in a part of the lecture, which is not directly included in a presentation, but I will upload in order to understand where this equation comes from. Basically, this expression here is the discretized or the discretization of this. No? Do you remember the difference between the system and the observer? And if I can place inside the unit cycle, do you remember in the methodological lecture, I introduced the concept of the unit cycle and so on. We obtain the asymptotical stability. This is the condition. No? The eigenvalue of this matrix, the resulting matrix here, using LD, particular LD, such that the eigenvalue of this matrix here, the norm, the norm 2 of the eigenvalue of this expression is less than 1. The norm 2. Yeah, because you remember the unit cycle, no? The unit cycle, the norm 2. Anyway, about that, I didn't tell you much, but intuitively you remember inside the unit cycle. Now, the problem which we had, exactly here, no? I remember this lecture here. It was a little bit boring, but I told you a lot about it. The idea is to calculate L11, Ln2, in discrete form. Do you remember? TS came from the discretization. We used forward discretization. In the question, build a model forward Euler is just a theoretical question. The observer, you can do exactly with which we did in the lecture with forward. Yeah, remember this boring thing at this moment is not what I would like to complete. Now, the idea, what I would like to tell you, because was a little bit open, and a practical. It's not a practical because it's also a theoretical thing, but it's not the question in the exam. Remember, we had in a simulation this line, let me say, to be tracked. And the observer, starting from a different value, but it doesn't matter where it starts, it is going in the other direction. I don't know if you remember. And then after, let me say, an interval of time, the observer understands that the direction is wrong, try to correct. Do you remember reducing the speed of the of the observer? This means reducing the dominant all eigenvalues, in particular dominant eigenvalues. No? The dominant eigenvalues is the smallest one in absolute value. No? You remember this? I can reduce, and I can let me say obtain something like this, or also something like this, which we don't have this effect, which is a non-minimum phase effect, in the sense that the observer reacts in the antiphase. No? Yeah, how I can a little bit explain this? Do you remember last time I tried a little bit to to analyze this quickly at the end. Do you remember that the observer consists, and in general, let me consider an observer of the second order in Laplace domain, because how possible to say the system is linear? I can represent everything in Laplace. If you remember, let me see a system of the second order. Just put some value, doesn't matter how. The observed value x2 of S, x2 for instance. You remember last time was the first, was in a current, no? The second state was the omega, no? Exactly as I told you today. We have two inputs, very important to understand this, to recall this. Here, excuse me, I told you the norm two, no? the cycle. Just to remember today what we did last time. Why two inputs? One is U, let me write. Assuming that this is just theoretically, not just theoretically. And yeah, we had the error, remember? Now I showed the error typically we consider E capitalized. It doesn't matter which kind of denominator, no? Just conceptually. Just conceptually. Now, the critical part of the, I mean, I estimate x2 considering the model in which in the model, of course, here we have an L, no? To remember this, and then I show you. Let me show you this. I didn't analyze here in S. No? I analyzed in time. This is more effective in any case. But let me show you what I intend here. Two inputs. Just sketched, of course, a little bit more complex because here I basically estimate both, no? x1 and x2. I will estimate both x1 and x2. Let me consider just one. Very important to understand that we have two inputs, the U and L with multiplied error. Of course, we have L11, L21 in the column because this error here corrects, let me say, or it influences both dynamics. But let me simplify it a little bit, the sketch a little bit the system. Now, the problem of this effect here came from this part here. Why that? Just roughly, of course, here a little bit more complicated because we don't have just, let me say, you have, let me, two error. Oh, the error is one, but this is going to x2, L, let me say x21. It will x with L11 is going to x1. But let me show you this a little bit. Now, what is E of S? Is, as I told you, I'm measuring x1. No? The current was last time, the current. This is the signal. This is the variable. Now, this is a signal. This means as if you consider now let me say this expression here. And if you consider, for instance, exactly in our case, the simplified case in which, to remember, x1 derivative of t equals yeah, x2 how possible to explain now? I don't remember. Let me see. Mm, it is difficult to see from here. But this, let me see a little bit how I can try to show you what I intend. Yeah, this L21 will multiply, let me say, not exactly this error here. Let me see. How possible to, yeah, nevertheless is correct. I try to express. Exactly this. Yeah, because is the, let me show you the idea. Where is, yeah. Yeah, is here, that's the contrary, x minus x hat. This is the exact definition. It's not a problem because the sign is included in L. But let me use the same formalism. This means x1 yeah, x1 measured, which I measure, minus x1 observed, right? But this is you remember, the real come from the measurements, the different, what I measure and what I observe, as I told you last time. Yeah, This means, let me see if I'm able to. In terms of x2, I mean, let me see in time, if I am able to show you in time. This was in time. Hmm? This means the derivative of this is something which I know because I measure. Right? Yeah. Now, the effect of this element of x2 can be seen from here. It's basically is x2 hat, right? This means if you want, you can consider now the Laplace transform of this, which is S, you remember, in control, but if you don't remember, I told you, remember this. Because this is x2. You remember the derivative theorem, no? The Laplace transform of the derivative S multiply the Laplace transform of x, of the function. This means conceptually, you can write here S multiply x1. Okay, if you like. From here, but hat. This means that you can consider here an enumerator which consists of my S multiply something minus something which I know. This means this is the measurement. This means this numerator, if you remember a little bit in Laplace, consists, just of course, an explanation a little bit colloquially, of a zero on the right part. I don't know if you remember this concept here. This means even though the system is stable, in this case also, you can consider, yeah, the system with different, I don't know, probably should be nicer if I consider something with real, so we can easily represent. Do you remember this root locus in case of real roots? I don't know if you did this analysis. Again, it's not included in the exam. A real part, imaginary part. I don't know if you remember increasing the gain, in this case, the coefficient L11 or L21. This means speeding up the Gauss placing the eigenvalue, do you remember, close to zero. Do you remember this, just to repeat what we did at the end of the lecture? 1 second. Probably, I have here. You remember, if I consider the eigenvalue close to zero, I speed up the dynamics of the error. Why that? Because zero maps, or let me say corresponds in continuous to lambda eigenvalue minus infinite. Do you remember this? I told you last time. This means in this concept here, this means that this pole here migrate very close, or in this area. But what is the meaning of this dynamics here? I don't know if you remember in control. The meaning is exactly this non-minimum phase effect. This means to minimize this effect, we have to stay in this region here. To stay in this region here means to slow down a little bit the dynamics of the observer. This is an interpretation. I can be a little bit more precise, but yeah, again, it's not included in the exam moment. I don't want to put other more mathematical, let me say, aspects. Yeah, yeah, because here you can see basically an x2 minus a constant, but x2 is s multiply, we can see this here. This means this transfer function, which depends in input we have x1 and output x2, x1 hat, x2 hat, we have something like s minus a constant in the numerator. And this states this zero on the right. Just roughly, just interpret why we have this effect. I don't know if you remember in control or in different courses, when the dynamics yeah. Let me see if I can improve a little bit. Of course, we have to be careful because here we will be unstable. No? This means we have to remain in any case here and strictly in this part, close to this. Again, here is prohibited. Here is prohibited because otherwise the dynamic is unstable. We can try. No? This means for very large L, we obtain, we have an unstable system. Okay, this was a little bit just to remember last time I tried to a little bit explain. It's not the goal to clarify this part here because the observer we can see from here is in a system, let me say, multi-input, single output. No? This means it's in a complicated system which we didn't consider in our course, but I would like to sensibilize you that this problem came from this part of the transfer function. If you consider the transfer function, it is possible to consider the transfer function because how possible to say, because we have two inputs, u and the error. Just to sketch a little bit in presence of this, we have to consider that the system could become also unstable. Because I don't know if you remember root locus. Anyway, if let me say in accordance with our knowledge, with the poles which reflects the eigenvalues, is positive. I don't know if you remember this root locus. But anyway, it's not the topic of our course. This means it's just a possible interpretation or supplementary idea. But again, this I need more time to introduce the multi-input, single output, a multi-input, multi-output. We didn't do, I don't know if in your knowledge you have the transfer function, probably yes. Just sketch out that why this peak negative, it could becomes unstable if we pretend too fast dynamics. Let me see if I forgot to say something. Anyway, this is outside of the program. Is no question about the picking, no question about the transfer function, and in particular, no question about the multi-input single output, a multi-input, multi-output, because it's multi-output, because we have two outputs. Now we observe nevertheless x1, and also x2, of course, with two inputs. This means we didn't do this multi-input, multi-output system, or at least this is another chapter of the control system, of course, could be nice, but the program which we have is this one. Okay, now I open the question. Let me close the. No, we remain here. I would like to record. Again, I will send you the email with the official indication in the software in MPC and optional. You don't need to do. I update exactly today because tomorrow is the official day to close the my camp. Um, yeah, I will inform per email today, and then yeah, we have 2 weeks theoretically. I hope that I can prolong a little bit at least. Please, in order to do officially, I need some mails. Somebody asked, but typically 2 weeks. We have seen that is exactly, almost exactly what we did. Please try to comment, no, the results. Let me see. Yeah, in the report. Let me see. In fact, I wrote discuss, no? Discuss, yeah, discuss. Build, discuss. I mean, it is implicit that, let me see exactly the formulation. I think so. I don't find now the email. Where is? We come back. Mhm. I am opening. Yeah, it's not explicit in some question is discuss, in some question is design, but implicitly, yeah, means discuss, design, control. This means in any case, try to go a little bit more in depth, use the simulation, the result. Uh, for instance, here, discuss the stability, or design a discrete controller which guarantees you have to explain me what you are doing. Design the Lundberg is clear because the idea is to produce a report. It is clear that I have to understand that you understood. Okay, I would like to open the session of the question now. I can record also the question because it could be useful for students who are not here today concerning organization, any kind of question. Otherwise, contact me in Loifana, please, so I can answer because in which I connect not every day for the when we are ready with the project, Loifana and this the mail. In any case, Loifana is okay because I answer with the receipt. Receipt I wrote. You have the right to receive a mark. And again, in September, I will change the day before as today. I will change and I will offer you another meeting because I think you have to choose which one, no? Which call, let me say. Questions, any kind of questions also now, but send me per email. Tomorrow is the official starting exam period. This means theoretically should be done in the next 2 weeks. Send me an email if you need more time, and then I will extend for everybody, of course. I try to write an email to Piotr to say some students ask me 1 week. I think more than 1 week. And this, of course, should also valid for September, I hope. I mean, anyway, correctly, in accordance with the calendar, you have to send me per email in 2 weeks. Do you remember the email? You know better than me. Piotr wrote the date. No? I think I showed you, I showed the mail of Piotr. Let me see. One thing probably is here. Yeah, I don't know if you see the email, probably is. At this moment, is here. Mm. Um, in the email, in the object, please write huge exam. So because I receive a lot of mails, the risk that for questions, but also in particular for sending me the report. The report of the exam consists of a report, and it's a software which supports the answer which we discuss today. This is at this moment is the deadline. If you need, I try to extend, but send me in the next days, not the last days. And yeah, for any questions, now I'm available, and also per email, and we can also meet per Zoom if the thing is complicated and so on. Yeah, I think if you want, we can meet officially also, as I told you, another time, because last week I was in in hospital. But I think concerning the material, uh, I don't want to add. But again, if you have a question, we can organize officially another meeting, because you are right to have another meeting, because last time I was in the hospital. Uh, or to go in depth on the project. If somebody have questions, I can organize again another meeting. I don't know in which day. Also in this day at this time, and there's no problem. Otherwise, question now or per email anytime. No? Again, I'm available also for another meeting, because you have right another meeting, because again, last week I was in the hospital for this problem, this eye. And yeah, but anyway, it seems to be at this moment not bad, but we can see a little bit this eye, and not so. But I can hold the lectures today in the future, I hope. Okay. If no particular question, try to do your best anytime. Question me per email, write huge question for questions, huge exam. I don't know how possible to distinguish. The reason is I have a lot of mails in order to, yeah, huge, let me say, huge questions, huge exam for the final submission. We can remain in this form. So I cannot, in any case, I hope that to find any mails, of course, to get any mail, but sometimes in traveling, could be useful with this object to recognize directly, could help. Okay, if no questions, please question me per email, because it could be that now it's too early to look at it, or to have questions in this case. I hope that the course was not so boring. I hope that you have seen something news. In particular, do you remember this interesting, I hope, interesting lecture on the Segway, this walking robot. But this is a little bit the program which I received, and then I interpreted in this form. Yeah, I would like to say good luck. For the first call, we clarified everything. For the second call, I will mail to everybody again. The meeting is the day before starting the period of the exam, in which we will discuss different, but not so deep, a little bit. I have to change the text, because I cannot put the same exercise, no? Because otherwise the second call, how possible to say, is already that the student already uh, prepared the answer. This is not correct, even though if you look at my course and the question, we already did together everything, but very important that you discuss the solution. I did so, I obtained so, as exactly as I did in the exam. Excuse me, in the lecture, which is already something to prepare the exam or the projects and so on. Good luck. And keep in touch. Keep in touch. If something is not clear, please mail me. I will answer you, or we can meet again. If I realize that we have many questions, open problems, I propose that we can meet next week in order to check the status, let me say, of the projects. No problem. I am available to do. I hope again that the course was not so boring. I hope that we will see something more, I would like to say, interesting for you, and in the future you can go ahead with these topics. Again, if you want to do thesis with me, it is also possible, no? In cooperation with which we had here this month Pavel, which is working with us. And this means we have this cooperation. This is established. We started 10 years ago.
Okay. Thank you for everything.
Thank you.
Goodbye.
Really. I liked a lot. I like every time this course. It's a shame it is not possible in the present, but in the first year, I came. That was very nice, and also with my wife, which is half Polish. It was very nice, which really. We keep in touch. Don't really don't hesitate to contact me. Something is unclear. I update now my camp, and I send you again the information.